So first of all, I'm going to have a Post-it note on my computer that says that we end at 45 and not 30. None of y'all called me on the fact that we ended 15 minutes early yesterday. I was like, what? I get off and I'm wandering around, I'm puttering, and I'm like, this feels like I'm done too early. Why? Oh man. I'm used to starting on the hour and then getting done at the 15. And like when I start on the half hour and get done at the 45, like it completely messes with my brain. So
I didn't even notice. This week has been wild.
oh man, I'm feeling you. I feel like I just say that every single week. And at some point I've got to just not have a wild life, maybe.
All the daycare kids are like sick this week and keep coming in like screaming and stuff. So it's been a good week. Yeah.
Oh goodness. No, thank you.
Yeah, they're not
No,
quite
thank
sick enough
you.
to send home, but just sick enough to have like lime green snot running down their face.
No. Oh, we're done. We're done. We're done.
Mhm.
No,
It's been a
thank
fun
you.
week.
No, thank you.
Yeah.
Oh, goodness. Okay. So as I said before, today I want to start with going over the most commonly missed problems from the last quiz. And then I'm going to finish up. I'm going to jump around into A and finish up different problems that I think you'll struggle with. Remember in Eagle Online, I'm just making sure these are in here before I make a liar out of myself. When you go to the content for a section, there are solutions to the notebook pages. So if there's ever any problems that we don't go over and you want to check your solutions, they release on the same day that the homework is due. And so you can go and compare your notebook pages and any problems that you didn't get done to the solution pages in Eagle Online. So any problems that we don't finish as a group, you can go and check the work there to see if you got the answers right. So, and then I have them do a little bit later only because if we like take longer to finish the notebook page, I don't have it released the day that I do the work, or else then people just copy it down and they don't come to class. So I just want you to know that that is a resource that is there for you. So the first problem I want to talk about has to do with simplifying expressions. So the expression I want us to look at is 22 plus 4 cubed divided by -20 times 5. Now, some people had easier problems than others. And when I say easier problems, some of these, when you do the division, it simplifies out into a nice number. And then other people got problems that were fractions. And this is one of those fraction ones. So when we think about order of operation, remember we have parentheses, exponents, multiplication or division. And it's always as it goes from left to right. And then addition or subtraction, again, as it goes from left to right. So for this, I've got Melissa, to answer your question, this is one from the quiz from last week, not the quiz that's due today. So we're going to do exponents first. So we get 4 cubed. So 4 times 4 is 16 times 4 again is 64 divided by -20 times 5. You cannot simplify the multiplication and then do the division. You have to first do division and then multiplication. Again, multiplication and division are considered equally important. And so we always do them when we're looking through it as they occur from left to right. So sometimes division will come first, okay? So from here, I'm going to do 22 plus 64 over -20 times 5. Now, why did I write it just over -20? -20, if I try to divide it into 64, it's not going to go an even number of times. In fact, if I divide it in, I get 3.2. Now that's nice that in this situation, our decimal terminates, but not everybody had an example where the decimal terminated. Some people ended up getting something that was a repeating decimal. So remember, when you're multiplying these, we basically have two fractions we're multiplying here. The number 5 can be written as a fraction as 5/1, and we can simplify before we multiply. And what that looks like is that 5 goes into itself once, and 5 goes into 20 4 times. So we end up with 64/-4. Simplifying. I can now divide. And 64 divided by -4 is going to be -16. And that's going to give us +6 as our answer. Again, you could have written the 64/-20. You could have simplified that to the decimal that is 3.2 or 3.2. But again, some people ended up with examples that had like 3.5 repeating or 3.3 repeating or something like that. And so with those situations, if you're rounding your answer before you do the multiplication, when you go to enter your answer into Eagle or into my math lab, it's going to get mad at you and tell you that it's wrong because it is assuming that you are not rounding and you're waiting till the end. Kaylee, what's your question?
So do we all have different, like, are there different quizzes for the same quiz? Does that make sense? Do they have different problems?
We have, my math lab uses a random number generating program.
Okay.
And so they have everybody's will have the same type of problem, meaning it's going to be something plus something cubed divided by something times something, right?
Okay.
But it has random number generators, and therefore what numbers you might have will be different than the numbers that somebody else has.
Okay.
So when I go over these, the numbers might not always match what you have on your specific problem, but the process is always going to be the same.
Okay, that's all I was wondering, because
yeah,
I don't know.
Any other questions about this one? Okay, our next one I want to talk about is, it says to evaluate -t² minus 3 times t for t equals -7. The biggest problem I saw was people not treating this as a -1 times t squared. -t² is -1 times t². The square is only relating to the variable itself. That negative in front of it is saying take the opposite after you square it. So when we plug -7 in, we're going to have -1 times -7² minus 3 times -7. Simplifying our exponent, -7 times -7 is going to be +49. And now we can multiply. -1 times 49 is going to be -49. 3 times -7 is going to be -21. Again, I'm just bringing that subtraction down through. Now I can simplify the minus -21 into +21, which this then reduces to -28 as our answer. So I get the question of, well, how do you know when the negative should apply to the square or shouldn't apply to the square? If they had -t², this would change that -7 to a +7 first and then square it. But, so again, this means -t times -t. But -t² again is -1 times t times t. Okay, so that's the difference in that notation. Okay, so next one is going to be 6 minus 2 times 3x minus 2 equals -2. So we're just solving. In order to solve, we need to distribute. In order to make sure we distribute that minus through, I'm going to rewrite this as 6 plus -2 times 3x minus 2. The reason I'm doing that is it indicates to me that I need to distribute the negative to both terms. So again, I'm taking this whole thing, I'm going to multiply each term by it. So we'll have 6 plus -2 times 3x minus -2 times 2 equals -2. Again, this subtraction sign comes down here, okay? So simplifying, -2 times 3x is going to make -6x. -2 times +2 is going to make -4. And this is how this, how the distributing of the negative through make sure that this turns into a +4. So again, the most common mistake I saw was not distributing that negative through, and therefore that second term, that +4 in our example, ended up being -4 instead. So that's why I use the trick of writing it as a plus -2 before I distribute to make sure that I get that negative to go into both terms. So we'll combine like terms. I have a +6 plus 4, which reduces to +10. And then I'm going to solve from here. So I'm going to let everybody finish solving this on your own. Send me your answer in a direct message, please. So from here, I'm going to subtract 10 from both sides. Bring that -6x down. I have -2 minus 10. So remember, when we're subtracting, we're going more negative. Therefore, this ends up with -12 as our answer. And then from here, we'll divide both sides by -6. -12 divided by -6 is going to be a +2, because again, a negative divided by a negative is always a positive. Okay. Okay. So that was all the most commonly missed problems. Okay. So let's go back to our notebook page. And we're going to look at number 5. Okay. So number 5 at the bottom of the page says, suppose you bought 10 6-packs of soda each 6-pack containing 6 12-ounce cans. How many gallons of soda did you buy? A lot of questions. So before we can even get to converting to gallons, we have to figure out how many ounces we bought to begin with, right? So a 6-pack is 6 cans, right? And each of those cans is 12 ounces. So to find the total ounces, we're going to take the 6 cans in a 6-pack, multiply it by 12. And then we need to multiply that by 10 because we bought 10 of the 6-packs. So technically speaking, we bought 60 cans of soda or pop, whichever one you call it. And each of those cans was 12 ounces, which gives us a total of 720 ounces. So if we look at our conversion sheet at the back, is there a direct conversion from ounces to gallons? What do we think?
I don't have it with me, but I thought that 16 fluid ounces were in a cup.
So 8
Or
fluid
2
ounces
cups.
are in a cup.
Okay, so it was 2 cups.
Yeah, so we know that 1 cup equals 8 ounces. And we're like, okay, great. How does that help us? Well, 2 cups equals 1 pint. And let's see, what is it? 2 pints equals 1 quart. And 4 quarts. My cues look weird. Quarts equals 1 gallon. So again, this is what we call a chain conversion, right? We have to use multiple conversion factors in order to get to the answer. So we're going to take our 720 ounces and put it over 1. Again, we always put the unit of measure we're trying to convert over 1. That's our starting point. And then from here, we're going to use all 4 of those conversion factors in order to get to gallons. So our first one, we're going to cancel ounces. So we'll do 8 ounces in the denominator and 1 cup in the numerator. So that will cancel the ounces. Now we need to cancel the cups. So we'll put 2 cups in the denominator, 1 pint in the numerator. Again, we're using this conversion factor right there. This will cancel our cups out. We now need to get rid of pints. So we know that 1 quart equals 2 pints. And then finally, to get rid of quarts and have gallons, we know that 1 gallon is 4 quarts. And that's the one that I remember most easily because quarts sounds like quarter. So there's 1/4 of it, right? There's 4 quarts in a gallon. Again, to me, that's the only one I can remember easily, or the 1 cup equals 8 ounces. The middle part I get messed up on all the time. So we need to go through and divide, right? We're going to take 720 divided by 8, divided by 2, divided by 2, divided by 4, or we can simplify through and have 720 over 8 times 2, which is 16, times 2 again, which is 32, times 4, which is 128. And if we simplify, we get 5.
So Erin, I'm sorry, I must have missed something. How did you get your denominator?
How did from the conversion factors.
Okay, so did
So,
you just
are you talking
multiply
about
the numbers on the
128?
bottom? Yes.
Where did I get? Yeah. So that came from multiplying these numbers together.
Okay, so when you're cross like multiplying, but you're cross simplifying, I think that's what I'm trying to say. You're only taking out the ounces or the measurement
Only
then?
removing the unit of measure.
Okay.
That's the only piece that I'm cross canceling or canceling out or whatever. It's not the number itself. And
Okay.
technically, when I cancel this, the cup with the cups,
Uh-huh.
that is cup divided by cup. So they cancel each other out.
Mhm.
And that's why I'm able to do it.
Okay.
Yeah. So I could have a running total where I do 720 divided by 8, and then I take that amount and I divide it by 2. And then I take that amount and I divide it by 2 again, and then I divide by 4, right? But what if we aren't keeping track of that properly in our calculator? We also have the choice of multiplying straight across. 720 times 1 times 1 times 1 times 1 gives us 720 over 8 times 2 times 2 times 4, 128, and simplifying at the very end.
So we're looking to eliminate the extra units of measurement and then just multiply normally as a fraction.
Multiply straight across the top, straight across the
Right.
bottom, divide at the very end. Yeah.
All right. Thank you.
Yeah. So this gives us 5.625 gallons. A lot of pop. All right. I find this Colby Bryant example really interesting, but I want to make sure I use our time to use the stuff that people struggle with more. So I'm going to jump down to conversions with area and volume. I encourage you to do the Kobe Bryant one, just to give you an idea of how much those players actually earn. It's insane. So when we talk about area conversions, and it says convert 1 square foot to square inches. So I want you to picture what 1 square foot is. So if I draw a square and it has measurements of 1 foot by 1 foot, the area here is 1 foot squared, meaning the space inside is 1 foot squared. So to find the area, I'm taking 1 foot and I'm multiplying it by 1 foot, which gives me 1 foot squared. Now I'm trying to get from feet to inches. And I know that 1 foot equals 12 inches. Therefore, if I substitute 12 inches in for feet, then I know that 1 foot squared is equal to 12 inches times 12 inches, or 1 foot squared is equal to 144 inches squared. So what we've done is we've created a new conversion factor for converting area. So if we think about cubic feet to cubic inches, again, I've got 1 foot by 1 foot, and now we're going 3-dimensional, right? So 1 foot cubed comes from doing 1 foot times 1 foot times 1 foot. But again, using the idea that 1 foot is equivalent to 12 inches, we can substitute. So 1 foot cubed is really 12 inches times 12 inches times 12 inches. Which gives us, what is that? 1,728 inches cubed. So remember, this is a volume, okay? So we're taking this box that's a foot by foot by foot, right? And we're putting these little tiny cubes that are an inch by an inch by an inch inside it, right? Like we're stacking them along and stacking the other way. So it's filling the whole thing with 1,728 inch cubes. So it's those little cubes. And that's why when we think about converting with volume, if we're converting to a smaller unit of measure, our answer is going to get bigger because those small units, there's a lot of them that can fit in that big unit to begin with. So if you look at number 2, 1 square yard to square feet. So we know that 1 yard equals 3 feet. So 1 square yard comes from doing 1 yard times 1 yard, And if we substitute, excuse me, we have 3 feet times 3 feet, which gives us 9 feet squared. So for a visual, let's say this is 1 yard. Okay, and this is 1 yard. Well, if I divide this yard into 3 pieces, and divide this one up to 3 pieces, and this one up to 3 pieces, and that one into 3 pieces, each one of these is a foot, right? Because there's 3 across. So we can see how that square turns into 9, right? Because each of those is a foot on either side. So the whole area there is that 9 feet squared. And again, the same idea goes with the cubic. So 1 cubic yard is 1 yard times 1 yard times 1 yard, which with substitution, we get 3 feet times 3 feet times 3 feet, or 27 feet cubed. So how do we use these definitions to solve problems? Well, number 5 says Billy wants to carpet a room that measures 10 feet by 12 feet. It's a big room, too little long. But the carpet he wants to buy is sold in square yards. How many square yards of carpet does Billy need? So there's 2 ways we can go about this. We can convert the length and the width to feet before we, from feet to yards before we find the area. The problem with that is that 10 is not evenly divisible by 3, right? If we divide 3 into 10, we get 3 1/3. It doesn't go in evenly. So this would be one where it's a benefit to find the area and then convert the area to square yards afterwards. So if we find the area, that's going to be 10 feet by 12 feet, which gives us 120 feet squared. Now we want to do square yards. So we go up to our conversion factor we've created, right? It says 120 feet squared times 1 yard squared over 9 feet squared. So dividing, we get 13 1/3 yards squared. Questions about that one? Converting with area is kind of a weird idea. All right, let's look at the next page. It says find the area in square feet of a rectangular yard that measures 20 yards by 12 yards. So this backyard is 12 yards by 20 yards. And we want to find the area. So again, we know that 1 yard squared is equal to 9 feet squared, right? How did I come up with that? Remember, 1 yard equals 3 feet. So 1 yard squared is 3 times 3, or 9 feet squared, right? Because we're measuring area. So setting up our conversion, we're going to do 12 times 20, which I believe is 240. Yes. So 240 yards squared. Now times 9 feet squared over 1 yard squared. So simplifying, we have 2,160 feet squared. Okay, so I want you to try number 7. It says Jane is preparing a vegetable garden that is 40 feet long and 16 feet wide, and she needs enough soil to fill it to a depth of 1 foot. The landscape supply store sells soil by the cubic yard. How much soil should she order? Okay, so let's talk about this one. First of all, we look at the garden bed. It's 40 feet long. It's 16 feet wide. And they want to put a foot of soil in it, right? So if we find the volume, that's gonna be 40 feet by 16 feet by 1 foot, which gives us a total volume of 640 feet cubed. Okay. So we need to convert that to cubic yards. So again, 1 yard is equal to 3 feet. Therefore, 1 yard cubed is equal to 1 yard times 1 yard times 1 yard, or 3 feet times 3 feet times 3 feet. And again, this comes from converting each of those yards to feet, which comes up with 27 feet cubed. So we'll take our 640 feet cubed, and we're going to multiply it by 1 yard cubed over through 27 feet cubed. 640 divided by 27 gives us 23 .703, and then it's 703. It's repeating. So we're going to say it's approximately 23.7 yards cubed.
So when we are doing these problems, like in our math lab and stuff, should we use decimal points or fractions, or does it matter?
I think on these ones, it's gonna ask you to round to the nearest place value. So decimals most likely is what it's gonna have you use in your homework.
Okay.
But just pay attention to what it says. You know, that little blue writing that's down next to the answer
Mhm.
box will tell you if it wants it in fractions or decimals.
All right.
Okay. So again, if you want on your cheat sheet, not your cheat sheet, but your conversion sheet, write out what our area and volume conversions are, right? That we got on the previous page. You know that 1 foot squared is equal to 144 inches squared. These are going to be helpful if in the moment you don't have to calculate this out every single time. 1 yard squared is going to be 9 feet squared. 1 foot cubed is going to be, what do we come up with? 1,728 inches cubed. And 1 yard cubed is going to be 27 feet cubed. So number 8 says an air conditioning system can circulate 300 cubic feet of air per minute. How many cubic yards of air can it circulate per minute? So go ahead and try that one and tell me what you think. So 320 cubic feet of air. We want to convert to cubic yards. So we'll use our conversion factor here. It says 1 yard cubed is 27 feet cubed. So 320 divided by 27 gives us 11.851 repeating, or approximately 11.85 cubic yards. All right. Last one is a hot tub pump can circulate 4 cubic feet of water per minute. How many cubic inches does it circulate per minute? So again, this one, we've got 4 feet cubed in 1 minute. And we need to multiply it something so that we get inches cubed, but still 1 minute. So we're not messing with that lower conversion factor. So if we go back to our conversions that we have written down, cubic feet to cubic inches is 1 cubic foot is 1,728 inches cubed. So we're gonna have 1,728 inches cubed over 1 foot cubed. So we'll go ahead and multiply these together. And we get 6,912 inches cubed. So again, have those conversion factors easily around while you're still working on understanding the idea of converting, setting up that conversion, right? Of going from 1 foot cubed to inches cubed, meaning to multiply 12 times 12 times 12, okay? So any questions from me before I let you go at the appropriate time, unlike yesterday? Oh my goodness. Okay. Tomorrow I am covering 2B and hopefully getting into 2C. I don't want to get us too far behind. The teaching schedule this semester is really tight for some reason. It just feels like I'm lost for time, or we're going slower than usual. I don't know. Either way, we'll make it up. It's not a big deal. But I just want to make sure that we can touch on both 2B and 2C tomorrow. Again, your quiz 2 is due tonight. Make sure you write down your work. I did have this question already. What do I do on the problems that have graphs? Again, you're just going to do your best to show your work. I would maybe write out what your thinking was if you're worried about having something to show as to why you answered a certain way. So that can be helpful in terms of helping to justify your answer. Okay. All right. Well, I hope everybody has a good day, and I will see you tomorrow.
Thank you.
Bye.
Bye.